Okay, hey everybody, it's Miss Lewis. I just want to continue this unit, and so now we did rational. We did rational, and so now we're gonna start the radical part of it. And then this video is gonna be about like the basics of radical expressions, and then I'm gonna introduce complex numbers. All right, so it's kind of important that you understand the difference between a square, square root. So let's look at that real quick. So a square is like 1, 4, 9, 16, 25, all these guys. All right, so like 2 squares for 7, excuse me, 7 squared is 49, 13 squared is 169. The square root, like the square root of 36 is 6, right? And so the square root is that symbol. Okay, and so there's an imaginary little 2 right there. And so when you see this guy, and there's nothing written there, that's the same as like an imaginary little 2. Let me make that better. There's an imaginary little tiny 2. We'll also end up talking about cubed roots, fourth roots. You can go fifth root, sixth root, so on and so forth. It's not necessary that I need you to know all these squares and their square roots, like the square root of 144 is 12, or the square root of 64 is 8, or the square root of 25 is 5. So if you don't know them, no big deal. Just know how to put them in your calculator to get them, or know how to calculate them. Like, okay, I'm trying to figure out 9 times 9. So then on the side of your paper or whatever, do 9 times 9, and then 81. And then you're like, okay, I need to figure out the square root of 81. The square root of 81 is 9. And know that relationship right there. I guess we'll keep red. All right, so square roots. Notice right here, we'll come back to this later, but you can't take the square root of a negative number. It's called an imaginary number. Complex numbers, we'll get back to that later. But if the negative sign is on the outside, then you just pull that negative out. I mean, like it just sits out here on the outside, and we take the square root of 36, which is 6, and then we have that negative there. I want to get to the basics. Don't worry about all that. All right, square root, remember, that's like a square root, and there's an invisible 2. So like right there, there's an invisible 2 right there. Just like if we had x, there's an invisible x to the first, and there's an invisible 1 right there. Okay. And so the square root is the same as x to the 1/2 power, and we're going to take out groups of 2 because x squared and square root, those are inverses, just like multiplication and division are inverses, or addition and subtraction are inverses. Cubed root can also be written as x to the 1/3, and we do groups of 3. Fourth root can be written as x back to the 1/4, and it has groups of 4. And then the nth root of x is x to the 1/n, and it's got in groups. And so I'm going to explain what all that means later. I'm just kind of highlighting some information. Anytime we take the square root of a number squared, it's really just that number. Anytime we take the cubed root of a number cubed, it's just that number. Anytime we take the fourth root of a number to the 4th power, it's just that number. Anytime we take the nth root to a number and then put it to that n power, it's just that number. All right, so remember I said square root has an inverse of squared. So the cubed root has an inverse of cubed, so b cubed. And again, I'm just kind of previewing some information and some notes. All right, so right now we're just going to find the indicator value, and what we're going to do is we're going to plug it in, plug it in. So everywhere there's an x, I'm going to put a 2. All right, so this 2 is this guy. All right, so 3 times 2 is 6, minus 2. And 6 minus 2 is 4. And the square root of 4 is 2. So f of 2, that's what this means right there. When we substitute 2 into this function, that's what that means. F of 2 means we're going to take 2 and substitute it where the x is. We get the number 2. We just happen to get the same number. All right, let's do this one over here. G of 3 means that everywhere, oh, this needs to be an z, if there's a z right there, sorry. Everywhere there's a z, we're going to plug in, substitute 3. So 6 plus 3 is 18, plus 7. 18 plus 7 is 25. Square root of 25 is 5, and then we have that negative sign right there. So g of 3 is equal to negative 5. That means when I plug in a 3, everywhere there's a z, I get negative 5 as my answer. All right, it's just kind of practicing what a square root is. So when we have square roots, what I don't want you to do, and what most things don't want you to do, is just take your calculator and type in square. Whoa, I had an issue with my calculator. Is type in square root of 20. And so if you do that, you get 4.472135, blah, 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 blah. That's hard to read. All right, but don't do that. Okay? Don't do this. No, ta-ta. What you need to do is, on the side here, 1 squared, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 10 times 9, 10 times 10. All right, I normally just write a whole bunch to the side when I'm doing square roots just so I can look at it easy. And so I need to figure out the biggest number, the biggest square root that will go into 20. And so 20 occurs right here. And so I'm going to go up. I'm going to use, let me turn on my webcam for y'all. Whatever. I look gorgeous today. I don't know if y'all noticed. All right, so I'm going to do 20 divided by 16, and I get a decimal, so that doesn't work. Okay, and I got 16 from right here. Now I'm going to do 20 divided by 9. I get a decimal, doesn't work. I'm going to do 20 divided by 4. I get a whole number and it works. So those are that's the biggest square root that will go into 20. 4 times 5. All right, and 4 is a perfect square. And the square root of 4 is 2. So I'm going to do 2 and then keep 5 in jail. He can't come out because he's not a perfect square. So the simplification of square root of 20 is 2 square root of 5. All right, and that does not mean 2 point something. Okay, 2 square root 5 is still 4.47, which is what we got up there. All right, let's do 32. All right, so 32 occurs right here. So I'm going to go this way. So I'm going to do 32 divided by 25. It's a decimal. Okay, I'm just doing it on my calculator. 32 divided by 16. Okay, it's a whole number. And some of you can do this in your head. I'm just showing you every single step. 16 times 2. All right, the square root of 16 is 4, and then I have 2 has to stay in jail because he's not a perfect square. So that's how square root of 32 can simplify. I do want to state that I could do, if I didn't pick 16, I could have picked 4. So let me show you what happens. 32 is 4 times 8. Square root of 4 is 2, and then we have 8. But 8 can also be divided by 4, and we could do 8 is 4 times 2. And so this 4, I can do 2 again. So I have that 2, and I have that 4, and then I have that 2 stays in jail. I have 2 times 2 is 4 square root of 2. Extend that, and I still get the same thing. So if you don't take out the biggest square root, it's totally fine. You just got to keep going, and you'll have multiple steps. Right. Remember we talked about square roots equals groups of 2. Right, because there's an invisible 2 right there. So x to the 6th is 1, 2, 3, 4, 5, 6. And I want groups of 2. 1, 2, 3. Because they can get out of jail. They can get out of this right here. This is called the radicand, by the way. They can get out of that radicand, that square root, in groups of 2. So you can't pass go collect $200 unless you're in a group of 2. So there is 1 group of 2, 2 groups of 2, 3 groups of 2. The answer is x to the 3rd. All right, let's do the next problem. And let's see if you can see the pattern. All right, w to the 13. Back. Okay. So groups of 2. 1, 2, 3, 4, 5, 6. So there are 6 groups of 2, and there's 1 stuck in jail. So this is our answer. Hang on 1 second. All right, let me do this problem, and then I'm going to go back and see if I can show you the pattern. All right, square root of 8 is 4. I like to split it up into, we have square root of 8, then we'll have x to the 4th, then we'll have y 12, and then I put it all together. All right, so square root of 8 is 4 times 2, and I picked 4 because square root of 4 is 2, and then this 2 stays in jail. X to the 4, 1, 2, 3, 4, and I need groups of 2, 1, so there's 2 groups of 2, and then y to the 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I need groups of 2, 1, 2, 3, 4, 5, 6, so there's 6 of those. All right, so I need to combine x squared, y to the 6, 2 square root of 2. And the only thing that's left in the radicand in that square root is 2 square root of 2, is that square root of 2. So I have 2 x squared y 6 square root of 2. And so that's the answer. I want you to notice something, okay? I'm going to go back to that other slide. Notice that, let me get a different color. Notice 6 divided by 2 is 3. 13 divided by that 2, 6, remainder 1. 6, remainder 1. 4 divided by 2 is 2. 12 divided by 2 is 6. So I'm going to finish this and my thought in the next video.